Okay, so this is going to find the area of a figure rotated around an axis of rotation, and you're going to find not the area of the flat figure, but the volume of the rotated shape. We're going to start with disc. Think of disc like a tennis ball or a soccer ball. It is a solid figure, so you're going to find the area as pi r squared. R is the radius of the shape. To find the volume of it, you're going to take the integral from a to b of pi r squared dx, or dy, depending on which way you're slicing it. I'm going to take the pi and set it out front because it's a constant. Dx or dy. R is the radius of your shape, and that's going to be the top minus the bottom of your rectangle, of your slice. Okay, so number one, find the volume of the shape formed by the function y equals the square root of x. That's that guy. The x-axis, that's that guy, from 0, x equals 0, to x equals 1. So we're looking at this shape. I'm going to rotate it on the x-axis, which is this one. So I'm going to draw this little shape so I know which axis I'm rotating it. Okay, and this is really important. You're going to always draw your rectangle, your slice, perpendicular to your axis of rotation. So I'm going to slice it vertical since my axis of rotation is horizontal. So my volume is going to be pi r squared. So pi, the integral from 0 to 1. Okay, now my r of this figure is the top minus the bottom. So that gives me the height of my rectangle. So the top minus the bottom squared dx. And then I'm just going to come in here and clean. And then I'm going to take the integral. And then I'm going to integrate. And I get pi over 2 units cubed because it's volume. Number 2, find the volume of the shape formed by the function y equals x. And the x-axis from 0 to 1. I'm rotated on the x-axis, so that's a horizontal line of rotation, which means my rectangle is going to be vertical. This is a disc because it is a solid figure once I rotate it. There's no hole there, no gaps. So I'm pi r squared. So volume is going to be pi. Integral from 0 to 1, it flat out tells me it won't always do that, but for this one it does. And then the height of my rectangle, this is the line y equals x. So the top is going to be x, the bottom is going to be 0, dx. And then I just clean a little bit. And then I take the integral. And then I evaluate. Units cubed. Okay. So far, piece of cake. Number 3, find the volume of the shape formed by that function, and g of x equals 1, that's the same thing as y equals 1. It's if it's revolved around the line y equals 1. Okay, so I know this is the parabola that opens down, shifted up 2. Normally I care about where it crosses the x-axis, but this one I don't because I'm going to chop it at y equals 1. So I'm interested in the shaded region between those two. I'm revolved around the line y equals 1. It did not give me an integral or a from here to here, so I have to figure out what x values these are so I know what my integral goes to. This is still a disk because when I rotate, again, I'm vertical because my axis of rotation is horizontal. When I rotate this, there will be no gaps. Okay, so I'm pi r squared. So volume equals pi. Again, I got to find my from what to what. So I'm going to take my 2 minus x squared, set it equal to 1 because I'm trying to find these points of intersection. So negative x squared equals negative 1, x squared equals 1. Root that, that'd be a plus or minus 1. So I'm going from negative 1 to 1. Okay, the top of my function is going to be 2 minus x squared minus the bottom of my function is a 1. So that's the height of my rectangle. Let me square that dx. So I'm just going to clean. That's going to give me a negative x squared plus 1 squared. And then I'm going to lobster that because I have to take the integral. So x to the 4th minus 2x squared plus 1 dx 1/5 x to the 5th minus 2/3 x cubed plus x from negative 1 to 1. Plugging in a negative 1. Let's see, common denominators of 15. That's going to give me negative 7, positive 8. And that's going to give me a negative 8. And then I bring down that minus. So 16/15, and then don't forget the pi. Okay, so this one was different because the axis of rotation wasn't on the x-axis. But again, to get this is the top minus the bottom squared because there's no hole. Once we have a hole, that's different. Okay. Number 4, find the volume of the shape formed by that function and the x-axis when x is between 0 and pi. If it's revolved about the x-axis. Well, you know that the sine curve looks like this. That's 0. That's pi. The next one would be 2 pi. The square root of that is just going to square root all these values. It's just going to make it lower because it's going to square root all your y's, and it's not going to give you any negatives because you can't square root something and get a negative out. But I'm only going from 0 to pi, so I really don't care about going negative anyway. So it's kind of this little smushed hump. And the x-axis, and we're revolved around the x-axis, and I'm going from 0 to pi. So it is a disk, so pi r squared. So from 0 to pi, with a pi out front, and then my r, okay? So if this is my axis of rotation, my rectangle is going to be perpendicular. So the top is going to be the square root of sine x minus the bottom would be 0 squared dx. So pi, if I just clean up, it just gives me sine of x dx. Take the integral, that would give me negative cosine. So negative cosine of pi minus a negative cosine of 0. Cosine of pi is 1, so negative 1. I'm going to go ahead and make that a plus. And cosine of 0 is 1. Nope. Cosine of pi is a negative 1. So a negative 1 would be a positive 1. Sorry. And then that would give you 2 pi. Okay, so now we're going to talk about a washer. And a washer, you can see really easily from this video that can draw much better 3D than I can draw. So there's the line y equals the square root of x. Then we're going to do the line y equals 1/10 x, so linear, with a very small slope. We're going to chop it off at x equals 4. So the area in between those 3 lines would be that red part. And then what we're going to do is we're going to take that red part, we're going to rotate it around the x-axis. And you can see there's a hole in the middle. So this is called a washer. If you slice it, which is what you do with your rectangle, you can see that you have a washer. So what we're going to do is the volume is going to equal the big circle minus the small circle area. So the big circle is going to be pi, we're going to call him big R squared, and then we're going to minus pi little r squared. Okay, but the big circle is from the outside edge of your figure all the way to the axis of rotation. That whole part, even though there's a hole right here, it stops. Then your small circle is going to be this part that we have to take out, kind of like a donut, and you're going to take out the cream that's in the middle. So you're going to do the whole thing minus the inside piece. So this is going to be outside function all the way down to your axis of rotation. That's big R. And then little r is going to be the leftmost or the bottom function all the way down to your axis of rotation. That's what you're going to subtract out. Okay. So I'm going to find the volume. Y equals square root of x. And y equals x squared. We're going to rotate it along that axis. Okay, we're going to go horizontal here in a little bit, so really focus on your rectangle is always going to be perpendicular to your axis of rotation. Okay, so we're still vertical right now. Okay, so my volume, and I'm going to put the pi out front, is going to be, I need to figure out from what to what. So if I set those equal to each other, and then subtract the x and GCF, I'm going to get a 0 and a 1. So from 0 to 1. Okay, now the big circle is going to be from here all the way down to your axis of rotation. Okay, so outer edge minus your axis of rotation, which for this problem is a 0. No, you don't have to put it, but that's not always going to be the case. So it's going to help us right now if we start with this. Okay, so that's pi r squared. So there's the area of my big circle. Now I need to subtract the area of my small circle. I already have my pi. The small circle is going to be this piece right here. That's the part I'm trying to take out. So that's going to be bottom edge down to axis of rotation. So x squared minus 0 squared. Then I have to put this in big parentheses with a dx. And just a note, when we go horizontal, everything's going to be in terms of y, and it's going to be a dy. So volume equals pi from 0 to 1. Square root of x squared is just going to be an x minus x squared. Squared is going to be x to the 4th. And then three tenths. So 3 pi over 10. Okay, so what to focus on? Big circle minus small circle. Big circle, whole thing, all the way down to the axis of rotation, and then small circle. All right, find the volume of the shape formed by y equals x cubed and y equals x squared. Okay, y equals x cubed is going to grow faster than a y equals x squared, especially in the 2 to 4 range. So y equals x cubed is going to be on the top, and x squared is going to be on the bottom. I'm going from 2 to 4. So I don't really care what happens after that, but I know at 2, x cubed is bigger, and at 4, x cubed is bigger. So I know I'm something like this. I'm rotating it around the x-axis. So volume equals pi. Oh, I need to find where they're equal. Oh, no, I'm going from 2 to 4. Okay, so big. Big is going to be from your top all the way down to your axis of rotation. So x cubed minus 0. And again, it's not always going to be 0, so don't get lazy on that part. Squared, pi r squared. Minus, I already got my pi. Now I need the area of the little guy, and that's this piece that I need to take out. So its top is going to be x squared all the way down to the axis of rotation. So pi 2 to 4, x to the 6th minus x to the 4th. Okay, this is the one, like 4 to the 7th is going to be ginormous. So feel free to plug this into your calculator. Use the integral function on your calculator and get, but make sure you go 3 decimal places. And I did put pi in there. And remember, when you integrate that. Okay, so now we get interesting. Now we're going to take it off of the x-axis, and we're going to go the line y equals -1. So this is now my axis of rotation. Okay, formed by the function y equals x and y equals x squared from 0 to 1, and I know that's where they cross because 1 squared is 1. Okay, so I want the area of this guy. Okay, so here's my plan. All the way down to the axis of rotation. So I'm going to find that area, and then I'm going to subtract that area out. So volume equals pi. Top function is x minus, careful, so x minus a -1. And then minus, because now I got to take the whole out, the bottom function, which is x squared minus a -1. Okay, you have to lobster this, and you have a negative which you need to run through. What do we say? 0 to 1? Yeah. Seven pi over 15. Again, one more time. This is top function minus axis of rotation minus bottom function minus axis of rotation. And each of those areas individually gets squared because it's pi r squared minus pi r squared. Okay, so now we get interesting and we get to rotate on the y-axis. So this is my axis of rotation. I have I have x equals y squared, which is the parabola this way. And I have x equals y cubed. And I'm going from 0 to 1. Well, I know they're going to both cross at 1 because at 1 squared is 1 and 1 cubed is 1. But I need to figure out what happens to my y values in between 0 and 1 as I cube them. They're going to be bigger. So my y cubed, and that's an awful drawing. There they are. So I'm finding that. Since your axis of rotation is vertical, your slice will always be perpendicular to your axis of rotation. So I am now going to slice it this way. So I'm going to do big minus little. Okay? So volume equals pi. Okay, big. Big. The farthest to the right for the big one is going to be my y squared minus 0, my axis of rotation squared, that's pi r squared, minus the little guy, which is going to be the whole, so that's going to be y cubed minus 0 squared. dy, because I'm in terms of y. Anytime you're going to horizontal slice, you're in terms of y. Y to the 4th minus y to the 6th dy 1/5 y to the 5th minus 1/7 y to the 7th from, I don't know what from. Here to here. So if I set y squared equal to y cubed, looks like it's going to be 0 and 1. So plug this in. 1/5 minus 1/7 minus 0. Nope, 5. 7. 2 pi over 35 units cubed. Okay. All right, number 9. Says find the volume of the shape of the function y equals x squared plus 1. I know what that is. It's a parabola, opens up, shifted up 1. Y equals 0, x equals 0, and x equals 1, rotated about the y-axis. Okay, here's the thing that perks your interest, because that's not a horizontal line, that's a vertical line. So I know that everything's going to be backwards. And the problem is, he is not backwards. So we're going to have an issue with him. But I'm going to leave him like this for now because I know what that looks like. Parabola shifted up 1. And y equals 0, which is a horizontal line. And x equals 0, which is a vertical line. And x equals 1, which is a vertical line. So this is my shape. So if I'm going to go on the y-axis, I have to put this guy in terms of y, which means I have to solve for x. And I don't have to put the plus or minus because I'm only on the right side of the graph. Okay, so if my line of rotation is vertical, then my slices are going to be horizontal. The problem is this slice is going to be different than that slice. This slice's top and bottom are different than this slice's top and bottom because right here the function changes. The bottom of the function changes from x equals 0 to x equals the square root of y minus 1. So I'm going to do this in 2 separate integrals. So volume equals. The first one, when I look at this piece right here, is not a washer. Because if this is my axis of rotation, there's not going to be a gap. So this is a disk. So this is just pi r squared. So my r is going to be from here to here. So from x equals 1 to x equals 0 squared. Okay, now I need my y's. So from here to here. So what I need to know is where is this when x is 0? So if you plug a 0 in here, you're going to get a 1. So I know that point is 0, 1. So I'm going to go from 0 to 1. dy, because I'm a horizontal slice. Then I'm going to add to that this area up here. Now I'm still rotating it around that axis, but this one's going to have a hole. So this one's not a disc, this one's a washer. And for a washer, I have to do all the way minus the hole. So all the way is going to be 1 minus 0 squared minus the whole, which is going to be, and again I have to have it in terms of y, the square root of y minus 1 minus 0 to the axis of rotation squared. Big parentheses, dy. Okay, so now I'm going to clean. One squared is 1. Careful here. That negative has got to distribute through after you square that square root. And I need my integral numbers for my second integral. So I need to know from here to here. Well, I know this is 1. So I can go down there and put a 1. And then I need to find the intersection of these two. So that's y equals x squared plus 1. And x is 1. So if I plug a 1 in there, I'm going to get a 2. Okay, then this is easy. 2 squared is 4. Be negative 2 plus 4 minus, watch your parentheses, negative 1/2 plus 2. So 2 minus 3/2. That's 4/2. So that's a 1/2. So 3 pi over 2. Whew. So the big thing on this one is to make sure that you understand why you have to do this one in 2 separate integrals. It's not the same top and bottom throughout the whole life of this graph. Number 10, find the volume of the shape formed by the function y equals x squared and y equals 4x. If it's rotated about the line y equals negative 2, that's a horizontal line. That's good. It says set up but do not integrate. Okay, awesome. So y equals x squared and y equals 4x. That's a slope of 4. So now it doesn't give me, oh, about the line y equals negative 2. As of right now, I don't have an enclosed section, but it's in between these 2 graphs. If I look at my sad little graph, they're going to cross somewhere up here. I just need to find that point. So this is what I'm finding. The area of what I need to do is set those equal to each other. So I know they cross at 0 and at 4. This has a horizontal line of rotation, so I know I'm going to slice it vertically, and I know it is a washer. It's going to have a hole. So volume equals pi times, all right, big one. The big one's going to be 4x, now be careful, minus a minus 2, so plus 2 squared, minus the little guy, and the little guy is x squared down to the axis, minus a minus 2, so plus 2 squared, and this gets a big old dx on it. So if I were to clean, you know, and you really don't, like, you don't even have to lobster this out. Plus 2 squared minus x squared plus 2. Yeah, like you literally don't have to do anything. I need my integral though. What did he say? What did we say? 0 to 4? Like that's it. You don't have to lobster. You don't have to run that negative through. You don't have to do anything. It just said set it up. So that's it. That's as far as you have to go. Okay, number 11 says take the same functions from number 10 and rotate them about the line x equals negative 2, set up but do not integrate. Okay, so I have the line y equals 4x, and I have y equals x squared. I know they cross somewhere up there. My axis of rotation is now a vertical line. So I am now slicing this thing horizontally. So I'm doing that minus that, which means I can't use those y equals. I've got to have x equals 1/4 y and x equals the square root of y, and he's positive, so I don't need the plus or minus because of my graph, where my graph is. This is a washer. Okay, I need from here to up there. I know he crossed at 0. Let's see. I need to know the y value. So if I take those guys and set them equal to each other, subtract him over GCF I'm going to get my 0, and then watch this. Set that equal to 0 and add 1, and then multiply both sides by 16. Boom. I'm going 0 to 16. Okay, so now I'm doing this one. I'm doing the big one. All the way down to the axis of rotation. So I'm doing, who is he, the curve? Nope, not x squared. I can't put x's in here. The square root of y minus a minus 2 squared minus the whole. The whole is going to be the inside guy, which would be 4x, but I can't use that. I have to use the 1/4 y minus a minus 2 squared, all with a pretty little dy. So volume equals pi 0 to 16. And this is the square root of y plus 2 squared minus 1/4 y plus 2 squared. Big old parentheses and a sweet little dy. And it just said set up. Thank goodness. Okay. Then I have one what if I want to show you that's not in your notes. Okay, let's say you have this. Y equals x squared. You are rotating, no, you are going to cut it off at y equals 2, and you are rotating it on y equals 5. So I'm taking this area. Okay, now this is different because the axis of rotation is above it. It would be the same thing if we were vertical and it would be to the right. Okay, my big area is that guy and my small area is that guy, but it's top minus bottom. Okay, so when I do this, it's going to be pi. Then for this big guy, it's going to be this one minus this one. 5 minus the x squared, minus the little one, top minus bottom, or right minus left, depending on which way you're going. So 5 minus 2 squared, and it's a vertical slice, so dx. Remember that your radius is a distance, and the distance is always big minus small. So that would be top minus bottom or right minus left. So just be careful of that when you get to your homework. And oh my goodness, your homework is just ridiculously important. So be super careful and put some time into it, and you should be fine. And come see me if you have any questions.